Alright, so the main purpose of this video is to talk about the idea of just particle motion. Particle motion deals with velocity, acceleration, and then position of the particles. So it's basically physics. Now, this technically does require a calculator, which I told you, so we're not going to actually do all the calculations. We're going to talk about the calculations required. Okay, so we can see here it talks about velocity. I'm a person, I kind of like to glaze through all the questions to see what's going on. So I see velocity, acceleration, I see position. It means I need to know my relationships. AKA, velocity can give me acceleration when I take the derivative of velocity. So the derivative of velocity is acceleration. If I take velocity and I want to get position, therefore I have to do integration. Okay. Another thing I'm going to do, because I'm a pretty smart fella, is I'm going to be like, that's probably not for nothing. That is in regards to position, which means I'm probably going to use that somewhere over here. And I'm also going to rewrite this as a coordinate point. Meaning, you see over here how it has all of these as t's, 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 t's. That means that this is actually like the x value, this is the y value. I know that's weird, right? So it's actually coordinate point 0, 8. Okay. So for part A, it says find the acceleration, which means all you have to do is take the derivative of this equation. So we'd be taking the derivative of velocity. So for part A, since it is ln, I do want to remind you that to take the derivative of ln, we use a u substitution, we get u prime over u. What it means is you could actually solve this one by hand, because u is t squared minus 3t minus 3, so the bottom stays the same. And then to get the top, we just simply take the derivative. We get 2t minus 3. And then it says that t equals 4. So the idea is anywhere you see a t, you're going to go through and plug in a 4. Okay? So all you got to look at doing for that one, alright? It's not too crazy. Alright? Part B talks about when does the particle change directions. And again, this is where we need to think about physics, meaning at some point in time it's going to be going to the left, at some point in time it's going to the right. So for motion, velocity we don't ever think of velocity as negative, but if something is going to the left, that's because it's going to give us a negative value. Again, we really don't want to think of velocity as negative, but I meant speed is negative, but velocity is, so it's a negative velocity. When it's going to the right, it's a positive velocity. So for part B, you actually don't need to know any calculus whatsoever. You just need to know how to set this equal to 0, and then check when is it positive, when is it negative. That's going to require factoring. So the idea of part B is you factor it, you set it equal to 0, and you have to analyze your ln's. So just make sure you're pretty good with your factoring. If you want to see more work for that, there's some work in the slides for it. Just know, no calculus. All you're doing is you're looking at when is the velocity negative, when is the velocity positive. Part C is position, okay, which means we have to integrate. The issue is it says at time equals 2. Normally we integrate over an interval, and that's where this comes into play, is because we actually don't have an interval. We're going to have to integrate it and find that plus c like we did back in the day. Okay, so I don't want to move up too much. So the idea for part C is you want to integrate your velocity equation. Okay, you want to integrate this ln thing. Okay. And you're going to get some equation Okay, if you integrate this, you're going to get an equation. Alright, I don't want to go through all the work for it. Alright, you're going to get some equation plus C. And the idea is you have to find that C value, so you're going to plug in 0 and 8. You're going to be able to find C. Now, there is a way to cheat this though. C is normally your y-intercept, which is actually what this is right here. So if you do solve this, you get C equals 8. Okay. Alright. Now, average speed, like I said, this comes back down to physics. This is, I'm going to write this one right here next to it since we're up here. Just remember that speed and velocity are the same thing, except speed is the absolute value of velocity. Okay, because we never consider speed negative. Alright, so you actually have to look at the average speed. Okay, now it gives us an interval. So this one is actually going to be like an average value theorem of integration. So the idea for part D here is the width is 2. And so the idea is we're going to integrate velocity, because that's going to tell me the total velocity. Integration is like the total of something happening. Integrate the total velocity from 0 to 2, and then we divide it by 2. Again, technically you would need a calculator. I'm just talking about the basics of how to solve the problems for you.